All right, where I last left off, I didn't want to rush. Where I last left off is I was figuring out the pieces here in this particular problem here. So let me erase and get back on it. Okay, so if I give you angle B is congruent to angle Y, AB is congruent to XY, they want me to use angle side angle congruence. So angle side angle says the side has to be between the angle and the side. So which one of these angles should I use? Again, angle side angle. Should it be C or should it be A? Should it be Z? Should it be X? Yes, it should be A. So this would be angle A and angle X. If we knew those two were congruent, then we could say these two triangles are congruent using the angle side angle theorem. Alright, and the last one we have says if you know section BC, if we know segment BC is congruent to YZ, angle B is congruent to angle Y, using side angle side, angle side means a side and angle, and the only other side that we could use would have to be this side here because it has to be sandwiched in between. The angle has to be sandwiched in between. So you would say segment BA is congruent to segment YX or XY. Alright? So what I'd like to do is go back a couple of pages because I skipped over a couple of them trying to hurry up. Alright, let's look at this. Tell whether the angles or sides are corresponding angles, corresponding sides, or neither. So look at this. Angle, that means angle. Angle N and angle P. Is angle N and angle P corresponding angles? The answer is no. I hope you understand why the answer is no. Because angle N has 2 marks and angle P has 3 marks. So the answer is neither here. Number 2, angle M and angle P. Notice they have the same number of marks, so those two are corresponding, which means they are congruent. What about segment OM down here, and segment RP? Are those congruent? The answer is yes. It's the side down here at the bottom here on both of those. So that's a corresponding side, and side NO and side QP. NO has these two, and QP has these two. So the answer to that question is no, because you notice how you're using, if you look at the angle marks, you got 2 marks and you have 1 mark for side NO. And then 2 marks and 1 mark would be this side over here. And they said QP, which would be this side over here. So no, this is not corresponding angles nor a corresponding side, because those two sides, NO and QP, don't correspond to each other. Let's look down here. Decide whether the congruent statement is true. I need to be able to tell, based on what they say here, is what I see true. Triangle IHJ is congruent to triangle JHK. Alright, let's look at it. Well, kind of how they wrote that. I don't like how they wrote that. But by side, these two triangles are congruent. How do I know side? Well, those two sides match. Those two sides match. And remember, I told you, anytime they share a side, those two angles will coordinate or are congruent or correspond to one another. But the way that they wrote it, I guess if the congruent statement is true, what I would say is they have to match. IHJ should be followed by KHJ. That's in my opinion. Side. We got angle LPS and angle PLN. Okay, yeah, this one is okay. The way they wrote it is okay. as I look at all these, I realize that all of them are side, 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 and they just want to know if the statement is true. So the statement is not true right here, and it is true here the way it's written. It follows the proper order. A, C, E on the first one, and B, D, F on the second one. Yes, this one follows the proper order for both of those. And S, T, V for the first one, and U, T, V for the second one. Okay, so I'm cool with that. Those all work out because they are written correctly. Let's keep going. Is it possible to prove that the triangles are congruent? Is it possible to prove? If so, state the postulate or theorem you would use. You got an angle, side, and an angle sandwiched in between. Angle, side, angle. So yes, and it's angle, side, angle for both of those. You see that? I have two angles and a side. You see how the side is not in between the two angles? This one is yes, and it's angle, angle, side. Now, this one, I have a side, an angle, a side, and an angle. And do I have anything else? Yes, I got this side that they share. So side, angle, side, side, angle, side. I can say yes using side, angle, side. These are all, I'm sorry, you didn't see any of that. These are all congruent, and I was able to do side, angle, side, this side that they share, side, angle, side, side that they share. All right, let's keep going. Okay, we did that one. All right. Which postulate or theorem can you use to prove that triangle ABC is congruent to triangle DEF? All right. I know that they have a congruent angle. Do you see anything else on here that you know that they are congruent? You might say, hey, they look the same, but we can't go off looks. The answer to this problem is D. There's not enough information. I don't know anything else about what I see here that tell me that those two are congruent. Now remember hypotenuse leg, which is one I haven't put on the notes, but the hypotenuse leg works with a right triangle. If I knew that the hypotenuses were okay, were congruent, and one of the legs was congruent, then you could say yeah, and you would use hypotenuse leg, which is not an option on there. So, alrighty, let's just keep going. I want you to see the whole idea of how to use this stuff. Alright? Let's look at number 7 and 8. Decide whether enough information is given to prove that the triangles are congruent using the side, angle, side congruence. Remember, side first, angle in between, side in the middle. Side, an angle, and a side. So yeah, I got enough. I got enough information here. I know enough information. Here, remember, straight angles make 90 degrees. So if this one is 90, this one has to be 90. So we got a side, we got an angle, and they share this side. So that's cool. But notice how this one is. Side, angle, side. But this one is not side, angle, side. Like, you know this side, you know this side, you know this angle. But you don't know the same stuff here. So I don't have enough information here. I got a side, I got an angle, and a side on this one over here. This one I'm shading in. But over here, I don't know that same stuff. I got a side and a side, but an angle that's not in between them. And so they don't correspond. So this one is not provable using side, angle, side. What about this one over here? I know this side, they share. Side, angle, side, side, angle, side. So yes, I can prove this one. Now, this one over here. I got the side and an angle. I got a side and a side and an angle. Is the angle in between the two sides? And the answer is no. So I cannot prove this one using side, angle, side. So I hope you are understanding a little bit how to use this. We gotta, based on what I'm given, I gotta be able to tell if I can use side, angle, side, or side, 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 or something like that. Decide whether there is enough information given to prove that the triangles are congruent using hypotenuse leg theorem. Okay, hypotenuse leg says you got a right triangle, which I do. You got the hypotenuse that they share, so we're cool there, and you know a leg, so yes, there's enough information to do the hypotenuse leg here. Over here, no, there's not. I don't have a hypotenuse. I don't have a right triangle. I just know that those two angles are congruent. You can only have a hypotenuse if you have a right triangle, so there's not enough information here. All right, let's just look at number 15. State the third congruence that must be given to prove that these two triangles are congruent, and I want to use the hypotenuse leg theorem. So they told me that AC is congruent to DF. So AC and DF are congruent. Angle A is a right angle and A is congruent to D. So if angle A is a right angle and D is congruent, it's also a right angle. So what else do I need to know in order to prove that these two triangles are congruent by using the hypotenuse leg theorem? Well, I need to know that the hypotenuse on both triangles are congruent. So I need to know that BE is congruent to EF. Alright, so I've given enough examples of the type of ways we would use this. We're simply trying to figure out, based on the information we're given, can I prove one of these, 4 right here, or hypotenuse leg, which is not written down. So you might want to find hypotenuse leg on the internet or something and write a number 5 and put hypotenuse leg down here or something like that. Or we can talk about it in class, but you probably want to add that. But remember, angle, side does not need to be in any kind of order. You just need 2 angles in a triangle and a side that are congruent in both triangles, and you're okay. Angle, side, angle, side have to go in order, meaning the side has to be in between the 2 angles, and the angle has to be in between the 2 sides. And so if you have 2 triangles and they meet any of these criteria, you can say triangle A over here is congruent to triangle B over here because either side, or side, or angle, side, angle, because it shows up over and over and over again. All right.